Wow. So a very warm welcome to you from Bangkok to all of you good people all over the planet, because literally there's planetary participation. We were absolutely amazed by the level of response to the invitation sent out. I'll show you a graphic in a few minutes' time to give you an idea of the spread of participation in this webinar. But to each of you, thank you for making time. It's wonderful to have you on board. Thank you for responding and being part of this very first webinar of what we hope will be a monthly series of webinars on different vector aspects. And this is our first one. So what I'd like to do is to hand over to our Senior Director for APMEN in Singapore, Amita Chebi, just to say a few words of welcome and introduction. So Amita, if you don't mind, I'm going to hand over to you. Thank you.
Thank you, Leo. Good afternoon, everybody. And thank you so much for taking time to join this episode of APMEN TechTalks, hosted by APMEN and the APMEN Vector Control Working Group. Since we seem to have a lot of participants across the world and potentially several who are new to APMEN, I thought I'd spend a couple of minutes just giving you a bit of a background around what APMEN is and how we came about. So APMEN stands for the Asia Pacific Malaria Elimination Network, and we were established in 2009 by a group of 10 countries that had subscribed to the vision of malaria elimination. So along with a few partner institutions, they came together to create this platform. Today, the network comprises 21 countries and more than 50 partner institutions in the region. APMEN is a fairly unique platform in that it brings together partners from academia, research, implementing partners, as well as, most importantly, our national malaria control programs to facilitate progress towards malaria elimination. In the past, a lot of our cross-country learning and exchange of expertise happened through meetings and workshops. We wanted to take this to the next level, and particularly recognizing our evolving work environment these days, we decided to launch a webinar series that would allow for greater participation and also provide a platform for discussing topics of interest. So we're launching two versions of the webinar series. One is called the APMEN Exchange, and this is going to focus on topics and issues around the policy environment, private sector community engagement, access to commodities. So essentially topics that are cross-cutting across technical areas around malaria. And then we have the APMEN Tech Talks, of course. So APMEN Tech Talks are going to focus on specific thematic areas that our working groups work on. So these are around vector control, VIVAX, and surveillance and response. Now the Tech Talks are expected to focus on technical areas of interest, research and implementation, guidelines, and essentially facilitate knowledge exchange and identify lessons learned from the field. Today's session of the Tech Talks is hosted by our Vector Control Working Group and is going to focus, as the name depicts, on vector control. So Dr. Leo Brack, who's our Senior Technical Lead for the APMEN Vector Control Working Group, will explain today's topic in more detail as well as introduce the speakers. Thank you so much again for joining us and hope you enjoy the webinar. Over to you, Leo.
Thank you, Amita, for your, as usual, very warm words, and you come across as just a very charismatic person, so thank you for doing your usual introduction. Thank you. So I thought just to give you a sense of who's participating this afternoon, at least Bangkok time this afternoon. On that world map there, you'll see apparently we are 39 different countries represented here in this webinar, 167 participants. So I'm hoping that this level of enthusiasm and participation will continue in the remaining other webinars that we hope to put on every month. But again, for giving us such a great start, thank you each and every one of you listening in and participating in this webinar today. What I'd like to do now is to introduce our speakers. As you know, we've got 3 speakers on board, and I'm going to introduce them in the order in which the presentations will take place. So the very first one is Dr. Brandy. So left of your screen there is Dr. Brandy St. Laurent, and I think they're on the screen in the column on the right there. You will see them in living flesh, as it were. So Dr. Brandy St. Laurent, who's a staff scientist at the Wellcome Sanger Institute in Cambridge, United Kingdom. Our second presenter will be Prof. Tirapap Charyan-Viryapap, who's head of the Department of Entomology in the Faculty of Agriculture, Kasetsart University here in Bangkok in Thailand. Tirapap is going to present some findings of a colleague of his in Vietnam who did similar studies there as well, Dr. Sheen. So to Dr. Sheen as well, thank you for making your results available. And then finally, Dr. Amelie Van Toe, who's a research scientist in the Malaria Molecular Epidemiology Unit in the Institute Pasteur of Cambodia in Phnom Penh. So to all 3 of you, Tirapap, Brandy, Amelie, thank you very much, Kopkun Kap, for making time available and your time in putting together these presentations. We look forward to it. What I'd like to also do, I'll try and be very brief, I tend to talk too much and I'll try and keep it short, is to contextualize the presentation. I've already had an email from Derek Shalwood. Hi, Derek. To ask, are we going to talk about the Furvela trap and the other kinds of traps? This is not an exhaustive, intensive review of all the trapping techniques out there. We simply don't have the time available for that. Unfortunately, I apologize for that. So the context of the talk is, it's APMEN, Asia Pacific Malaria Elimination Network. So the talk is targeted really at malaria vectors. And for malaria control, you need to understand which malaria vectors are present in a particular area, how abundant are they at any particular time, when do they bite during the night, etc., etc. You all know what I'm talking about. And historically, the gold standard has always been human landing catches. But again, as you know, there are ethical issues around use of human landing catches. You can use prophylactics, but you still run the risk of arbovirus infections. And as you also know, arboviruses are becoming more and more of a problem, more common and widespread. So there are serious issues with the use of human landing catches. So what we're doing this afternoon is, getting 3 speakers to talk about methods that, people have been talking about in recent years and trying out and seem to have the potential to deliver on trap catches that approach, and in some cases maybe even better than human landing catches, simply because of the volume of mosquitoes that you collect. So they're going to give presentations on their findings, and then you interpret the findings as you see fit. But I, for one, I'm really looking forward to that. So just very briefly then also how this webinar works. We're going to be doing the 3 presentations back to back. So all 3 presentations, boom, 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 one after the other, followed, and they're about 12 minutes each. And then after that, there'll be around about, we don't want to go beyond half an hour, but about half an hour question and answer. Unfortunately, because of the nature of Zoom and any of these platforms, we can't have everybody talking and on video, etc., bandwidth, etc. So our participants are muted and you're not on video, but you do have at the bottom of your screen I can't see it now, but somewhere at the bottom of your screen there's a questions a little box where you can formulate a question and submit it. And also, as a member of the audience, I can't see that icon, by the way, but apparently there's you can vote, or what do you call it, Tim? Upvote. If you think this is a great question, you can give a thumbs up sign, you upvote it that way. And the more votes a particular question gets, the higher it ranks on the right-hand panel. And that is what I will see at the end when we come to questions and answers. And it's according to that ranking that I'm going to then ask our panelists to respond to the questions. Otherwise, when we're potentially sitting here with 167 people throwing out questions, we have to rank somehow. So please, feel free to formulate questions, submit them, but then also try and vote so that we have some kind of ranking and prioritize on the questions that way. Maybe also just to mention that the webinar is being recorded. This is a live recording. It's recording as we speak. And the intent is to upload it onto our Aureen website. And this slide will be shown towards the end of the question and answer session. So you can write down the websites if you like. So the recording will be uploaded to the APMEN website and the Aureen website. I think that's about it as far as the background information is concerned. So I'm going to stop sharing my screen and ask Brandy if she can share her screen. So I'm going to stop sharing. So there we are. Brandy, if you wouldn't mind, share screen. Apologies to our participants. This is completely new to me, this Zoom platform. So I'm fumbling a little bit, but somehow we'll make it work. There we go, great. Okay, Brandy, over to you.
Okay, that looks all right. Hi everyone, thanks so much for having me. I am currently a staff scientist at the Wellcome Sanger Institute, but I am talking today about work that I did as a postdoc at the National Institutes of Health, talking about 2 different studies looking at using cow-baited tents to sample malaria vectors in Cambodia. In Southeast Asia, we have an exceptional level of vector diversity with multiple cryptic species groups that are overlapping in their geographic range. This means that in any one place we have a lot of different species, some of which we know about and others that we're still learning about. Most of these species bite and rest outdoors rather than coming into houses, and that makes our traditional monitoring and control tools not as effective in this place. This is also an important transmission environment to study because it's a hotspot for the evolution and spread of drug-resistant malaria parasites. And as we're learning more about those parasites and their range, we still don't know exactly which vectors are transmitting those parasites. And so it's really important to understand the entire transmission system there. I'm going to talk about 2 studies today that occurred in these 3 provinces in Cambodia, Persat in the east, Privahir in the north, and Ratnakiri in the northeast. Persat is notably just a little more developed than the other 2 sites, with Privahir being about in between and Ratnakiri less developed. So the first study is a trap evaluation that we did in the high transmission rainy season in 2013 at 1 site in each of these provinces. And the second is a longitudinal study that we did every month of 2014 in 2 sites in each of those provinces. So first I'll talk about the trapping study. Since infection rates in Southeast Asia tend to be very low in mosquitoes, sometimes less than 1 in 1,000 mosquitoes infected with falciparum, we need to collect thousands of mosquitoes to screen them and get any idea of infection rates by species. So we were interested in how to effectively collect them in Cambodia. We compared several different trapping techniques, some standard and some not as standard. The human landing collection, which is, of course, is our best estimate of human exposure to potentially infectious bites, CDC light trap, and our cow-baited tents, where a cow is staked at the center of a large tent, and we go in every hour and collect the mosquitoes that have entered that tent and are resting on the inner walls, not collecting directly off the cows, just on the inner walls of the tent. And we also tested human-baited tents, where a human was in that same large tent that the cow is in, but was protected in a small tent from infectious bites. And also barrier fences that have been tested in a few other regions. In this plot, we have each of those provinces, so Prasat, Privihir, and Ratnagiri, and each of these dots represents a single night of collection by these different trap types. The number of anopheles collected in that single night. So we found that the cow-baited tents collected hundreds of mosquitoes per night in each of the provinces. The human-baited tent and human landing collections were pretty comparable, collecting about 20 mosquitoes per site, per night. And then our barrier fences and CDC light traps collected very few Anopheles mosquitoes. So importantly, the cow-baited tents collected the same species as were captured in all of the other trap types. In fact, about twice as many species, 27 species total across this short study, and collected 10 to 20 times more Anopheles mosquitoes than the other collection methods. Additionally, the only falciparum positive mosquitoes that we had collected were collected in the cow-baited tents. So moving forward, we decided that we would use these cow-baited tents as an effective alternative to human landing collection because we needed to screen thousands of mosquitoes to get the infected ones that we were interested in. So for the longitudinal study that we did over 2014, we had 2 sites per province. We had 1 cow-baited tent per site and collected in 3 consecutive nights per month, every month for that year, and did hourly collections on the hour from 6 p.m. to 6 a.m. Again, going into those tents and collecting the mosquitoes on the inner walls of the tent. The study sites that we selected were based on clustering of locations where patients that had enrolled in clinic were mapped to their home and their workplace. So where we had clusters of those homes and workplaces, that's where we thought transmission was occurring and that we might be more likely to collect infected mosquitoes. Here's some of those cow-baited tents. We have to use whatever cows are around, so sometimes those vary. But again, just going in every hour collecting those mosquitoes. Over that year, we collected just over 20,000 Anopheles mosquitoes. This is just bulk data, all of the mosquitoes together in each of the provinces that are color-coded here. We were surprised to find that we had hundreds of mosquitoes per night throughout the entire year, with only a strong seasonal signal from our collections in Prasat. So this was surprising. We started the study in the dry season, hoping that we could have some lower catches to get used to the collections, but in fact, we caught many, many mosquitoes in each province. We also had, again, looking at just the total number of anophelines, many anophelines throughout the night. So this is every hour of collection. So many mosquitoes active, being collected very early in the night and early in the morning. We have to look at individual species to get an idea of biting patterns. So When we do that, we find that any interpretation of nightly biting pattern can be skewed by when and where those mosquitoes are collected. So for example, here's Anopheles maculatus collected in Privihir in the north and Ratnagiri in the northeast by these different months. The ones that are darker are during the rainy season. And in Ratnagiri, we see this crepuscular biting pattern. And in Privihir, we see more of a peak around 10 p.m. But again, even in those same places, during other months, we see a more flat profile and consistent biting through the night. So I would just be cautious about your interpretation of biting pattern by species because it's highly dependent on where and when those mosquitoes are collected. Here's some of our field team. Because we collected so many mosquitoes, we couldn't molecularly analyze all of them. And so we selected a subset of those 20,000 mosquitoes, about 40 mosquitoes per site per month. We took just the head and thorax and extracted DNA and did molecular typing for molecular ID based on ribosomal DNA ITS2 sequence. And also a plasmodium detection and then sequencing to confirm any plasmodium positives. When we look at those molecular identifications, we find that the 14 morphological species that we had collected over that year are in fact at least 32 molecular species, so multiple representatives of different species complexes and representing 12 different major groups of anophelines. When we look at that species distribution by site, we see that there are a lot of mosquitoes in each of these collection locations, with no fewer than 20 mosquitoes at each site and almost 30 mosquitoes at one site in Ratnagiri. And the abundance of different species throughout the year is pretty consistent. Many of these species are present the whole year from these collections. And the species distributions between Privihir and Ratnagiri are more similar than in Prasat, and this might be due to Prasat being a little more developed than these other two sites. Here's some of those species that we collect in Cambodia. So these results indicate that there are many species present at any one time, and the high level of diversity throughout the year is a challenge for our monitoring because anything we learn about infection rates is diluted out by the number of species that we're constantly collecting. And again, most of these species are outdoor biting and outdoor feeding, and so the cow-baited tents take advantage of that kind of generalist feeding behavior to collect them. We can look at a few different measures of diversity. So firstly, species richness. So this is just the number of species that we collect in any one place. Again, more than 20 at each of those sites. We can look at different indices of diversity. So Simpson's index of diversity is the probability that if you take one mosquito and then a randomly selected second mosquito, the probability that those are different species. And apologies, the trash is being collected outdoors. But in this case, in every site, it's highly probable that you will collect a second different species. And then we can measure species evenness. So are a few species dominating of those many species, or are they more evenly represented? Are there the same number of each of those species? So in Prasat and Privihir, it is less even, and in Ratnagiri we have more evenness. So perhaps a handful of species are more abundant in Prasat and Privihir, but in Ratnagiri we have more even distribution between those very different species. Also in these two different studies and another study using cow-baited tents that we did, we found many different species positive for Plasmodium. So we have quite a few species positive for Plasmodium falciparum that you can see here, with a handful positive for Vivax, and then just a couple Plasmodium knowlesi positive mosquitoes. So I think this is a really important thing to note, that we need to test all of the mosquitoes that we're collecting, because many of them are capable of transmitting, as we can see from field positives and lab infection studies, not just those species that we think are the major vectors. So there may be a lot of other transmission going on that we're not aware of because we're not screening these other mosquitoes. And just a final note that overall in the cow beta tents over multiple studies, we collected 37 different Anopheles species in Cambodia, which is an astounding species diversity caught in this trapping technique. So to conclude, Anopheles mosquitoes in Cambodia are incredibly diverse. The transmission in the field is very complex, with many species potentially acting as vectors. These species are abundant, they're outdoors and generalist feeding, which enables us to capture them using animal-baited traps. And then these traps can help us to better monitor and understand their species distributions and behaviors and catch infected mosquitoes in this place. I'd just like to thank my colleagues at the NIH and CNM Cambodia that were involved in all of the field collecting. And I'm happy to take any questions over email after this presentation is done. Thank you. Sorry, Leo, I can't hear you.
Sorry, yeah, so I was just thanking Brandy for a very interesting presentation, highly worthwhile findings there to ruminate on. I've just been reminded by Jost, one of our technical support people, consultants helping us with the Zoom platform. If you're addressing your questions to a particular person on the panel, please could you just say, Brandy, and then phrase your question so we know that you have a particular person that you'd like to address your question. So wonderful presentation. Thank you, Brandy. My takeaway message from that is that carbated traps, you get a 10 to 20-fold increase in the number of mosquitoes you're catching relative to most of the, or all the other collecting methods. You're collecting all the species that are being captured by the other techniques, at least in the Greater Mekong subregion, or Cambodia specifically. And that you're in fact also catching additional species that were not present in the catches of any of the other trapping methods. And in those additional species, you were finding Plasmodium falciparum. So carbated traps gets my thumbs up for the moment. Thank you for that very much indeed. So, I don't want to ramble too much, but these represent findings from Greater Mekong subregion, a great diversity of species. Most of them are zoophilic, so you can actually use cows as an attractant. It works, and it works very well. So I can imagine my colleagues our colleagues sitting in Africa saying it's not really relevant there. So there are publications that have actually shown that Gambi stricto and Funestus stricto do bite at cattle, albeit in low numbers. But because of the large number of mosquitoes that are attracted simply because of the volume, the size of a cow, the high numbers of mosquitoes that are attracted there, you do actually get a significant number of what are supposed to be highly anthropophilic mosquitoes attracted to cows as well, even in Africa. So, our colleagues in Africa, maybe, try it out, see how it works there. So, trials have been done, but I think it's worth pursuing. I'm going to ask Brandy if you can stop sharing your screen, and then again, thank you very much, Brandy. And then we move to Prof. Tirapap. If you could keep your video on and unmute maybe Tirapap, that would be great. And then pull up your presentation on screen. And then we should be ready for you. That COVID-19 has brought us, that we're discovering the opportunities for remote meetings and holding webinars like this. You know, really wonderful to be having this webinar. And as I said, we'd like to do this at monthly intervals on different topics. Tirapap, are you ready?
Yes, yes. Can you see the screen?
Okay. No, we don't have it up on the screen.
Oh, okay. Let me
Okay.
So what I'm going to share the share screen.
Yeah, you got to click the share screen and then
Okay.
select. Excellent.
Okay.
There we go. Wonderful. Okay, Tirapap, over to you. Thank
Okay,
you.
you see? Okay, can you see the screen? Okay. Okay, I start. Thank you, Leo, for your kind introduction. I really appreciate your time organizing this webinar. And good afternoon, ladies and gentlemen, and all friends attending this seminar. Today, I would like to speak about the comparative efficiency of double net trap and human decoy trap relative to human landing cache in Thailand and Vietnam. Thanks, Dr. Ching, for conducting the similar study in Vietnam. First of all, I would like to thank the admin and all resources persons from professional and technical support, Jeffrey He, Tom Burgott, Buffalo, Michael Banks, and Dr. Wannapa. Let me give you a brief background why we did conduct the evaluation of the 3 trap devices. As you may know, human landing collection is the gold standard to collect outdoor mosquito, but it is very intensive process and needs well-trained collector and sometimes not practicable for large-scale operational sampling of malaria vector. And recently, using human bait is restricted because of the ethical issue from local public. The objective of this study was to compare the 3 outdoor trapping methods, which were human decoy traps, human double net trap, and outdoor human landing cache. The key objective was to determine an outdoor trap efficacy in terms of anopheline collected per night per trap in comparison with the gold standard human landing collection. The study was conducted in 2 GMS countries, Thailand and Vietnam. In Thailand, the study was carried out at Sayok district, Kanchanaburi province, Western Thailand, close to the Thai-Myanmar border. And this area is considered as one of the most attractive tourist sites, approximately 200 kilometers away from Bangkok. In Vietnam, the study was conducted at Dak Lek province, about 1,200 kilometers away from Hanoi, as you can see from the map. In each country, 2 different ecological habitats were selected, which were forests and villages. In the forest, 3 local spots were selected, and each spot was 100 meters apart. The traps were located following the Latin square design. The similar study was also applied to the village. As you can see from the map, the distance between the village and the forest is about 2 kilometers. And this slide shows you the 2 new trap devices as compared to the human landing collection. Human decoy traps was prepared by using a camping tent connected with the water pipe and warm water tank at the end, wrapped with the black sheets. One human volunteer sleep inside the tent during the collection and the whole night. Human double net traps comprise two net layers, smaller inner net and the larger outer net. The human volunteer sit down inside the inner net to protect the bite from mosquito while mosquito attempt to feed. From the slide, you can see how the net dimensions are different. The inner net is 1.2 by 1.8 and 1.8 meter, and the outer net size is 2.2 by 2.8 and 1.5 meters. And as you can see here, there is a small gap between the inner net and the outer net. It's a gap from the ground up to the outer net. So this gap let mosquito get in. Let me give you more details about the traps method. The human double net trap and outdoor human landing cage are quite similar, except that the host for human double net trap remains inside the net, and the host performs the mosquito collection in between the two net layers once every 15 minutes. For the human decoy traps, one human volunteer sleep inside the tent during the whole period of collection. When ventilator fan system was connected to the pipe inside the tent, this system will carry and transfer the human breast away to the end of the pipe to attract female mosquito. And at the end, what you can see here, that is the sticky plastic film is used to trap mosquito outside the tent. The study was performed using the 3x3 Latin square design. The study was conducted to compare the three traps in two study sites, which were forests and villages for each country. At each site, 6 replicas were performed, comprising 18 collection nights. 3 nights represent 1 replica, as you can see from the table. In the table, you can see the location 1, location 2, and location 3. And at each collection method, there is a host. For example, at outdoor human landing collection, there are 2 hosts, A1 and A2. A1 refer to the host that conduct the study during the first half of the night, and A2 will do at the second half of the night, and then this trapping system will move to the second location and the third location. This slide shows you the mosquito result collected from Thailand. As you can see here, the most collected genus belong to Aedes, followed by Culex and Anophelines. In case of Anophelines, 434 mosquitoes were captured, in which 422 were captured from the forest and 12 were collected from the village. Talking about the forest, 255 were collected from outdoor human landing cages, 87 were captured from human double net trap, and 80 were from human decoy traps. Very few mosquitoes were captured from the village, 8 from outdoor human landing collection, 3 from human double net traps, and 1 from human decoy traps. This slide shows the Anopheline mosquito species collected from the 3 trap devices in the village and the forest from Thailand. 5 species were molecularly identified, and the major species captured belong to Anopheles harrisoni. Anopheles harrisoni is the member within the Anopheles, the minimus complex. As you can see here, there was very poor participation of Anopheles diarrhea, Anopheles maculatus. I will tell you later why. This slide shows the total number of mosquitoes collected by genus from the trap in Vietnam. very surprised because we have got 8,281 mosquitoes from Vietnam. And of these, only 35 mosquitoes belong to Anopheles genus, 5 were from the village, and 30 were captured from the forest, as you can see from the slide. This slide shows the Anopheles species collected from the tree trap at 2 sites in Vietnam. 8 Anopheles species were molecularly identified, with the major species is Anopheles sinensis, followed by Anopheles dirus. 21 were captured from human double-net trap. Only 3 were collected from human decoy traps. The upper table is the result from village habitat from the 2 countries. We collected a total of 7 Anopheles from human double-net trap and 2 from human decoy traps. In contrast, the below table is the result from the forest from Thailand and Vietnam. As you can see here, 104 were captured from human double-net, 82 were captured from human decoy trap, and 236 were captured from outdoor human landing collection. This slide shows the comparison of mean number of collected mosquito per trap per night among 3 trap devices from two sites in Thailand. What you can see here, there were no significant differences in mean number of Anopheles mosquito between human double-net trap and human decoy traps, but significant difference were found between outdoor human landing cats compared to human double-net trap or human decoy traps. As you can see, the same letter indicate no significant difference. This slide shows the comparison of mean number of collected mosquito per trap per night among the 3 trap devices from 2 sites in Vietnam. There were significant differences in mean number of Anopheles mosquito between human double-net trap and human decoy traps. But as you can see here, no significant difference between outdoor human landing collection compared to human double-net traps. In conclusion, from Thailand, largest number of Anopheles was collected from outdoor human landing collection, comprising 60.6% of the total collected Anopheles, followed by human double-net traps, representing 20.7%, and human decoy trap, representing 18.6% of the total collected mosquito. From analysis, there was no significant differences in mean number of Anopheles mosquito between human double-net trap versus human decoy trap in either forest or in village. So we conclude that human double-net trap and human decoy trap can be used for large-scale outdoor malaria vector surveillance and monitoring when it is difficult to use human landing cats in the forest setting in Thailand. In Vietnam, the human double-net trap was found to be the most effective to capture Anopheles mosquito, representing 60% when compared to outdoor human landing collection, representing 32%, and human decoy trap, 8% in both collection sites. However, significant differences in mean number of Anopheles mosquito collected were observed between human double-net trap and human decoy trap. As extremely low number of Anopheles work was collected, analysis on comparing the 3 trapping methods in Vietnam may not be precisely appropriate. My recommendation, field trial with the 3 trap devices should be performed in different seasons, hot, rain, and dry, to observe more details from different species of malaria vector, as well as the overall trap efficacy. I say this because if you can see from my presentation, we get very less number of Anopheles dirus, Anopheles maculatus, because we did this in the early rain season. During the wet season, we should get more Anopheles dirus, Anopheles maculatus. These two species are the most important for malaria vector. Forest testing should be considered to be the main site for evaluation of the trap efficacy, as most malaria vector in Greater Mekong sub-region countries occupy the forest habitat. To increase the strength or the power of the data, test result more field sites from other countries in GMS should be assigned. So last but not least, I would like to thank all my students who participated in this study at Phu Thai, Sayok district. Thank you for your attention, and I am happy to take any question from you guys. Thank you.
Okay. So Tirapap, as usual, a very professional presentation. Thank you sincerely for that very well presented set of data. My takeaway from that is unfortunately, the Vietnam study, the number of Anopheles individuals captured was so small. The total catch of Anopheles across all trapping methods was in the 30s. And it's very difficult to feel comfortable with any level of significance in interpretations based on such a small sample. But certainly from the Thailand studies, it's clear that at least of the 3 methods used, human landing catch is still superior to the other 2. Although what I found interesting there is because of the rise of importance in arboviral studies, a lot of culex and Aedes were being caught. So one mustn't just stare oneself blind against the use of these traps for Anopheles. They may have alternative application for arboviral vector studies as well. So Tirapap, sincere thank you to you. Appreciate your time and excellent presentation. You lead a great team at Kasetsart. It's a privilege to work with you, and we hope to work with you lots more. So I'm going to ask if you would mind stop sharing, and then we get Amelie to share screen, and then give Amelie, if you could give your presentation then.
Yes, sure.
We go. Okay.
Okay, thank you. Thanks for inviting me, and I will present some of our results comparing cow and human baited traps capture in Cambodia. So all of you already know probably, but in sub-region, so malaria risk is strongly associated to forested-related activities, and forest housing are usually not open. People don't tend to carry a bed net. So the idea of these studies was to understand better which malaria vectors were and when they were biting people, including in forest sites as well. And so we used other baited double net trap, which is similar to the one that Tirapap presented, with an inner net touching the ground and protecting the collectors. And we put the outer net 20 centimeters above the ground and 20 centimeters away from the inner nets. And mosquitoes attracted to the bait would tend to fly in between the 2 nets, and we collected them every hour. And what we did is that we set up human and cow baited nets side by side, because we are interested in understanding better the host preferences of the different mosquitoes collected. And we did these collections in villages, in the forest, just near the village, in forest sites where people would go to cut wood or farm and things like that. And in rubber tree plantations, where we put only the human baited net to not disturb the work with the cow, actually. And we did this for 2 days, and we did it once in the dry season and once in the rainy season. We collected a total of 3,920 Anopheles, 3 times more during the rainy season. And by morphological identification, they represented 14 different species or species complex. And you have a table here presenting the total number of mosquitoes during the 2 seasons in the different kind of traps and the different sites. And what is interesting to note is that in the forest sites, you don't have much change in the cow and the human baited traps in the mosquito numbers between the dry and the rainy season. And so the big difference is actually by an increase in the numbers of the Anopheles collected in the cow baited trap in the forest near the village and the villages during the rainy season. We screened all these mosquitoes except one, and actually we found 145 human Plasmodium species, so both in human and cow baited nets, and mainly represented by Plasmodium vivax parasites. And you have here a representation of the malaria prevalence on the y-axis, and I represented this with a different type of sites, the 2 different kind of traps in the dry and the rainy season. The number under the bars is representing the total number of mosquitoes collected, and the number above the bar is representing the infectious mosquitoes. And you can see in the forest sites that we have quite a lot of infectious samples collected in the cow baited trap, and of course, some of them in the human baited trap as well. And you can observe the same thing in the forest near the village, where cow baited samples also have human malaria parasites. And we have the same thing in the villages, where we found a reasonable number of infectious mosquitoes collected in the cow baited samples. Another way to look at this data is looking at the mean biting rate per day, the dry and the rainy season in the cow and the human baited traps, and looking also at the mean number of infectious bite per day. As expected with cow baited traps, we usually have a lot more mosquitoes in the cow compared to the human trap. But overall, and it depends also on the different sites. And what is interesting here is that when you look at the human traps in the rainy season, you can see that you have 6 times more infectious mosquitoes and biting mosquitoes in the forest sites compared to the villages. So same result as Tirapap found, really. As I said, we were interested in the host preferences of these mosquitoes. So we looked at the anthropophily indices. So the index can be calculated as a number of females collected in the human baited traps over the total number of females collected in both traps. An index around 50% is giving you a generalist mosquitoes, which has a random choice between cow and human. Below 50, it's going to give you rather zoophilic species. Above 50%, it's going to be more an anthropophilic species, or what would be considered anthropophilic. And I put here the species based on the morphological identification only, also the complex as well, in the forest sites and in the different seasons. And you have again cow and human and the total number of samples. And when we look at the anthropophily indices in both seasons in different species, you can see that most of them are really generalist or zoophilic, including Anopheles dirus, which is considered one of the main malaria vectors in the area and which is supposed to be highly anthropophilic. And we observe the same patterns in the forests near the villages and in the villages where we have most of the mosquitoes are actually zoophilic. We used a random subset of these samples for which we did the molecular determination of the species. We found 20 different species, with one of them having no correspondence in the, we couldn't blast, so we couldn't type. And you have their proportion here represented overall in this random subset. You can compare this species in the cow trap and the human trap, and you can see that you have almost all species represented in both kind of traps, with a few exceptions of these samples, which are in aqua blue, where we just had one mosquitoes in these samples, and they are just found in one of the 2 traps. And indeed, we have differences in the species composition of the 2 kind of traps. And you can see that some species are enriched in the cow trap, such as Nivipes, Peditenatatus, or Cocci, and other species are enriched in the human traps, such as Campestri and Dirus. What was interesting is that we observed that Campestri was enriched in the human trap, but it was also enriched in the uninfected samples. Dirus was enriched both in infected samples and in the human baited trap, so supporting his renown about being a main malaria vectors. And interestingly, Anopheles peditenatatus was enriched in cow traps. We got more of it in the cow traps, but it was also enriched in Plasmodium positive samples. So despite being zoophilic and collected mainly in cow-baited traps, it bites on human and gets human malaria parasites from time to time. So overall, what we can say from these collections is that, as expected, we have a higher number of collected females in the cow-baited traps, but they are also found in the human baited traps, and most importantly, they are carrying malaria human parasites. So they are probably a good representation of the parasites circulating in an area. There were a very low abundance of mosquitoes in the human baited traps, except in the forest sites, which means that using this trap requires a larger sampling effort than using a cow-baited trap. These mosquito population are mainly generalist or zoophilic. So we really have, as Brandy was also saying, we have to think about the vector control tools, how we sample them. They are not all anthropophilic and just biting indoor. They are different. It's not Africa. And if we look at the molecular determination of the species and the traps, you can see that when we have very few samples, they were found only in the human or in the cow-baited traps. But usually when we have decent numbers, they were present both in the human and the cow-baited traps, which is supporting the use of cow-baited samplings in some areas. And on a small note, I'm going to finish on a new collection that we started last year, and in which we are using human baited double net trap only in a lot more different sites, 7 villages, 10 forests, 10 plantation, and 10 field sites. And we do a 3 days collection. It was actually easier than moving a car around. So we went for this nets only. And since human landing catch is the gold standard method, we still felt that we had to preliminary results without any statistics because samples are too low. But you have here the average number of Anopheles collected per day per trap in the forests, plantations, fields, and villages using the HLC method or the double net methods. And you can see that most of the time you have more or less similar numbers, and sometimes we even have higher number of Anopheles collected in the double net traps.
We finished.
Yes, I was finished. Thanks.
So, sorry, I lost you there for a minute or two. So I'm not sure, I take it that your presentation is done,
Yes.
Amelie. So thank you very much for that, Amelie. Excellent information, nice background. So very useful insights over there as well. Pretty much confirms what Brandy said in her presentation about the large numbers of mosquitoes, Anopheles in particular, that the cow-baited traps captured. So to all three our presenters. Sincere thank you. Great presentations. Lots of insights there to chew on. So now we come to our question and answer session. And, you know, just going through the different questions over here, I'm going to use a little bit of moderator's prerogative and jump around a little bit, but let me start at the top here. So there's a very general question here, which is very difficult to concisely answer, but you know, let's give it a bash. What would panelists consider to be the perfect trap? And presumably it's a compromise of price. I mean, the questioner, the person asked you about automated species idea. I don't think there is such a thing in Anopheles vector species because of the species complexes and groups, etc. So that's not possible, although you could probably find a way to get to species group level. So let me ask, Brandy, I think you've had experience in Africa, you've you've trapped in Indonesia, Greater Mekong subregion. I think from my impression is you have pretty broad experience in mosquito trapping. Maybe give us your impression. What would you think is practical? I mean, you can't lug around a cow wherever you go. And there are not always cows available, even although it may be the best method. Do you want to just say something about, you know, vector surveillance and in your opinion, what is a kind of a reasonable compromise or method to use for most situations? So Brandy.
Yeah, so I think had human landing collections yielded enough mosquitoes, we would have still continued using those in Cambodia, but we really just were getting such low returns, especially indoors. People collecting hardly anything with indoor HLCs. So we just had to explore these other methods. Indeed, there's not always a cow in a village, but there's often a cow. I tried using goats before and pigs were really difficult to work with. But goats were also able to catch more mosquitoes than humans with pretty similar species distributions. But I think what we need to consider is, are we sampling those same mosquitoes? And I felt moving forward that we were confident we were collecting the same mosquitoes and getting a reasonable yield of infected mosquitoes, meaning that they were also biting humans. We did a little bit of blood typing and found a lot of multiple host feeding in individual mosquitoes. So we know that they're biting a wide range of things. And cows in Cambodia were pretty available. I said we selected sites where we knew we would have access and compliance with some farmers that had cows in the villages that we wanted to work in. Yeah, so I think I don't think Cambodia and Southeast Asia is totally unique that we would catch so many different species with a cow-baited approach, but I think in general, we just need to pay attention to these other species that we may not believe are vectors and screen them and then just measure every type of trap that we're evaluating against HLC, at least initially, so that we have some standard that we can compare all traps to.
Yeah, thank you for that, Brandy. Yeah, so I'm very enthusiastic about using cow-baited traps, even in Africa, and and I know you did work on goat-baited traps in Indonesia, and again, you got very good results over there. These are all published results that are published in Malaria Journal, if I remember correctly. So I think it's definitely worth investigating and broadening these trials, and ideally doing what Prof. Tirapap recommended is to replicate in a few different countries these trials, but incorporating cow-baited traps as well, and maybe even incorporating light CO2-baited light traps as well. But I think in the end, and this is biased opinion, I think cow-baited traps are still going to come out on top. I know from your work, from the work I did in Africa, goat-baited traps also work very well, maybe less numbers, but still beating human landing catches. So, but I'm not going to, in the interests of trying to deal with as many questions as possible, I'm not going to ask Prof. Dierapap and Amelie to respond to exactly the same question. Let's move on to another one. So Richard Oxborough asked, as many different species were positive for sporozoites, which species would you recommend targeting for insecticide susceptibility tests? So obviously, you know, we know that certain species have historically been considered to be prime vectors, say in GMS, Dirus, Minimus, etc. So, but you're finding, and Amelie, that there are many different species that have sporozoites. So, you know, we need to maybe broaden our perspectives and not be tunnel vision on just 2 or 3 species. We need to also consider the contribution some other species may be making in terms of maintaining outdoor transmission, especially in forested areas where you were finding so many anopheles and positive for sporozoites. If you had to broaden the range of species being tested for insecticide susceptibility, which species would you put into that pot? Let me go to Prof. Dierapap. You've done a lot of work on insecticide resistance. Do you want to give us your opinion? How would you broaden that species mix?
Thanks, Leo. But I think the first thing we have to think about the ecological habitat of malaria vectors. Most malaria vector in GMS countries is in the forest type habitat, and in the forest, as you can see, not too many insecticides have been used, except for the indoor spraying, the IIS. But when we talk about the IIS, most vector of malaria in this area, mostly they are exophagic behavior by outdoor. So very important that we have to know first behavior of mosquito. And when we talk about the insecticide resistance, it's very limited information. I don't know, but we found some for the non-vector malaria, but for the main vector of malaria, very limited. I heard one paper that by Dr. Wang Song Kobel that did collected mosquito along the Thai-Myanmar border, that it shows some insecticide resistant to pyrethroids. So to my knowledge, I think it very rare because of the behavior, the biting behavior and the resting behavior, and less people use the insecticide in the forest where most vector malaria occupy the forest habitat. Is that I answer your questions?
That gives, I mean, it's a broad response. It's good, very useful. I mean, what you say there is absolutely true. Most transmission takes place outdoors in forest situations. So, you know, where, you know, you need to understand which species are involved, where. So it's complicated. It's complicated, and you need to ask the right questions to guide you in this insecticide resistance or susceptibility testing. Let's move on to Jean Clark. She asks the Latin square design. I think this is targeted. I'm sorry, I'm going to ask you again. Amelie will get to you pretty soon. But Tirapap, if I can target you again, because you made explicit mention of Latin square design and you described how the traps and the volunteers for the human landing catches were moved between trap sites. So did the different human volunteers also cycle between the different trap methods, or were they, you know, the village volunteers, did they stay there? Just trying to get an idea of the randomness of the sample. So that, you know, was it a true Latin square design kind of setup?
Yeah. From the beginning, we have discussed this a lot, but what we did, we fixed the human volunteer with the traps, and when we move the traps, the human volunteer will go from one location to the second location. So this way we can minimize the bias.
Okay. All right. Thank you, Tirapap. Appreciate that. Let's move on to Sylvie Manguin. Hello, Sylvie. Sylvie asks, Amelie, what techniques did you use to, you know, for PCR identification of the Anopheles species? So there's a question to you, please, Amelie.
Yeah, we used amplicon sequencing techniques on the ITS2 sequence and the CO1 sequence.
Okay, Sylvia, I hope that answers your question. Here's one, seems directed at Brandy. Have you deployed the carbated trap both in village and forest? If you did, what are the difference of these two sites in collecting Anopheles? So just better clarity in terms of, I mean, Tirapap clearly found that there are higher numbers in the forest compared to village. So could you say a few words there, Brandy?
Yeah, so most of our sites were kind of in forest fringe areas, but by necessity we had to collect around houses to get our to have our collections be easy and accessible and get enough volunteers. There is some work from Mark Koosman's group, and Lise Dernes did a study that was in villages and in forest in Cambodia, and they found that there were more different species in the forest, but very similar species distributions otherwise between the village and forest. And like Amelie saw, higher numbers of mosquitoes in that forest environment.
Excellent. So thank you, Brandy. Next question. I'm going to stop fairly soon because we're running over time now. So another 2 or 3 questions, and then I think we need to, yes, yeah. So next question addressed to you, Tirapap. Between human double net trap and human decoy trap, it seems that the person wants to move away from human landing catch. Which do you think is more, gets a better yield, the double net trap or the human decoy trap? Sorry, I just wanted to Tirapap, because some people may not quite have understood that decoy trap. So you have a person sleeping inside a tent. There's a water pipe. Obviously, it has no water in it, it's just a pipe leaving the tent where you're sleeping, and there's a little fan, an extractor fan, that sucks the human odor from inside the tent and feeds that through, and that odor is then released over a hot water tank that provides the temperature, and the mosquitoes that are then attracted to the odor being emitted there with the temperature, they get stuck on a sticky trap that's around the water bath. So of the 2 methods, which do you think is more feasible for routine surveillance?
It is very difficult to answer. Very good question, but not very easy to answer this question.
I'm sure.
Yeah. But what we have found from our study in Thailand, quite similar between human decoy trap and human double net traps. No significant difference between these two, but For human decoy traps, you have to be careful when you remove the mosquito from the sticky, the paper film, the sticky papers in the morning. The way to remove, you have to take practice and practice. This is the I think the major concern for the human decoy trap. But what we did last time, because we have Francisco with us, so she explained how to remove the mosquito very gently. So no problem, but we take practice for the new collector. But for the human double net traps, my personal uh, I think it is very good, but we need more data. We need more confirmation if this technique is comparable to another two techniques. I don't know now any places have done this comparison. I don't know. I have no idea, but I think we have to have more confirmation on these two techniques.
Okay, yeah, thank you, Tirapap. So I think Amelie is the next one. We'll take two more questions. So Amelie, here's one for you. It comes from Professor Joe Lyons at London School of Hygiene and Tropical Medicine. It's more a comment, actually, where Joe says, I think as always, the choice of sampling method depends on your purpose. Very good comment. Talk 3 confirms that of talk 1. In order to maximize sensitivity, and if you just want to sample parasites, the cow trap is one of the best. But the relative sporozoite rates in different species does not tell you their relative importance as vectors. Very true. So Brandy says it's the same range of species. They are all potential vectors. But the older literature suggests that it's important to consider these categories of primary, secondary, and incidental vector species, for sure. For this, you need to catch them seeking blood meal from humans. So I would prefer a combination of cow and double net human bait. Yeah, you know, if you have the resources and so on, and you can do both, sure, absolutely. But, you know, in many situations, people already have a good sense of which species are the primary vectors, which species are the secondary vectors, and so on. So it's more a case of, you know, which species are there in this particular area, how abundant are they? So put out a cow there and you'll get your answer pretty smartly. But point taken, Joe, that, you know, if you want to do it the proper way, you know, use a mix of trapping methods.
May I add something?
Of course.
I think it's one thing to be careful about this old literature about primary, secondary vectors and so on. Is that in many studies, people are not even screening other vectors anymore. And they are inferring of not finding malaria transmission in some areas. But it could be because they're not looking at the right mosquitoes or not the right places. So while it's very good to rely on all literature, we have to be careful on not having too much assumptions either, or we introduce bias in our studies as well. So I do agree it's a combination of both traps, which is interesting, but we have to be careful about this primary vectors literature, which is especially in Southeast Asia. In the GMS, it's been very markedly noticed in the publications that we don't screen many vectors.
Yeah, yeah. All right. Okay, so I think we're now well over our allotted time. I want to ask, before we step away from this webinar, those people still with us, please may I ask if you can spend a few seconds, literally it shouldn't take you more than 30 seconds, to respond to a poll. And the poll is just to help us at APMEN to determine, you know, did we get this right, or did we miss something, and how can we improve? Did you like the webinar? What did we not get right? So if you wouldn't mind just responding to the short poll that we've posted over here. And I think on that note, sincere, genuine thanks to you as audience for spending an hour and a bit of your time sharing the information that was provided here. To our three speakers, many thank yous to Tirapap, to Amelie, to Brandy. Thank you for your time, genuinely. Thank you, everyone. Have a great day. Hopefully see you next month. Okay, bye-bye now.
Bye-bye.
Thank you. Bye.
Bye.
Bye-bye.
Bye, thank you.